Okay, so this is where we left off the last video. We determined that H2 is our limiting reagent, and we have 2.44 moles of H2. So what I recommend is, like if you're doing this on paper, circling in the original question, circling 2.44 moles and putting LR by it to show me that you know that 2.44 is moles of hydrogen is the limiting reagent. And the reason I say circle it is because once you figure out that hydrogen is your limiting reagent, 2.44 becomes your starting number for any other calculations. So remember, by definition, limiting reagent kind of controls everything. Once we run out of the limiting reagent, the reaction stops and it doesn't continue. So it kind of controls everything. So that's the most important number from here on out. So once you find out what the limiting reagent is, that becomes your starting number for any other calculations. So I'm going to clear that out. And part B says determine the theoretical yield. Now, theoretical yield is just a fancy way of saying the amount of product. So, again, like I said, since we figured out that limiting reagent is hydrogen, 2.44 becomes my starting number for any other calculations. So just like before, starting unit goes on the bottom. In this case, we're not going to convert into the other reactant, we're going to convert into product. So mole of H2, now we're going to convert the limiting reagent, H2, into product, into moles of H2O. So that's what I want to put on top. And from our from learning how to do stoichiometry last week, we know that we can go from moles to moles. That's when we use the balance equation. So moles over moles, I look at my balance equation. Well, H2 is a 2, H2O is a 2, so it's a 2 here, 2 here. That's some easy math. Okay, so 2.44 times 2 divided by 2 equals 2.44 moles of H2O. So once we figure out our limiting reagent, we use that to determine how much product we can make. In this case, we can make 2.44 moles of H2O. So that is part B. Part C is where we determine the amount of excess reagent. So, again, starting with the limiting reagent, which is 2.44 moles of hydrogen. This time, we're going to go from 2.44 moles of hydrogen and convert it into the excess reagent, which is the oxygen. So back in part A, we figured out that oxygen is the excess reagent. So here we're going to go from limiting reagent to excess reagent. And so here's our limiting reagent. We're going to go to the excess reagent, which is moles of O2. Now this should look familiar because we actually did this in part A. So you can just use your answer from part A. You don't have to do this again. I'm going to do it again because I erased it. I don't have it in here anymore. So moles of O2, that's a 1. H2, up here there's a 2 in front of H2. So I do that math, 2.44 times 1 divided by 2 is, again, 1.22 moles of O2. Now, if we look at the question, it says determine the amount of excess reagent. So just like with part A, I just calculated what I need. Okay, I'm going to need 1.22 moles of O2. But if I compare that to what I actually have, I have 1.53 moles. So I have 1.53 moles O2. I need 1.22. And the question is asking, determine the amount of excess reagent. So how much are we going to have left over? So how much of the excess reagent is going to be left over unused? So I just compare these two and I subtract them. If I do 1.53 minus 1.22, I get 0.31 moles of O2. So that is how much leftovers I'm going to have, and that's my final answer. So that's the amount of excess reagent that will be left over after this reaction occurs. So don't forget this subtraction step. A lot of people will do this math, do this stoichiometry, but then forget to compare what they need to what they actually have that's given to them in the original question and subtract the two. Find the difference between the two. Again, we have 1.53 from our given up here. We just calculated what we need, you subtract them, gives you how much leftovers you have. So that's it for limiting reagents. All these examples were mole to mole. I will tell you that there is one set of limiting reagent questions, so a part A, B, C. I get just numbers. I didn't break it up in the practice quiz as part A, part B, part C. But there is one 3-part question that, instead of moles to moles, is grams to grams. So look back at your stoichiometry stuff to figure out what you got to do there. It's basically, you're going to have a similar calculation. You're always going to have moles over moles. But first, you're going to have a grams to moles. And then at the end, you're going to have a moles back to grams. So it's going to be a 3-stepper. So it's a little bit more work. Most of the practice quiz questions are mole to mole stoichiometry questions. But the last 3 limiting reagent questions are grams to grams. So just to give you a little heads up on that. But again, that's it for limiting reagents. I got one more short video here talking about percentage yield and actual yield and theoretical yield. But if you have any questions on this, look over the notes. Again, I didn't go through all the notes, and there is this entire example here too that I go through and explain all the steps and whatnot. So if you get stuck, you can look at that too, or stop in, send me an email, any of those things.